Hey guys, Rhett Richardson here. Welcome to my first video from chemistry tutoring. I've been a tutor around the suburbs of Melbourne for about 7 years now, and I just wanted to make this short video to step you through a stoichiometry question. Now this comes from the Unit 3 course. It would be relevant for Year 11s who are learning stoichiometry as well as Year 12s undertaking Unit 3. Having said that, I'm sure this is a similar curriculum to other states around Australia, not just the VCE in Victoria, if not around the world. So really what I'll do in this video is just step through this question worth 8 marks and just show you step by step kind of the logic and thinking behind how you structure an answer and ensure that you get the most marks or most consequential marks. So really what I want you to do is just pretend you're a student sitting next to me. This could be an exam, maybe a test or a SAC question, and we're just going to go through this step by step by step. Okay, so the question for 8 marks, 20.1 grams of propane gas undergoes complete combustion in a home barbecue. Assume that you have excess oxygen available. So, the barbecue is outdoors, there's plenty of air around, so we're going to undertake complete combustion. Answer the following questions using an appropriate number of significant figures. A. Write a balanced chemical equation, including all states for the complete combustion of propane in excess oxygen. B. What mass of carbon dioxide would be produced in the reaction, for 2 marks. C. What mass of oxygen would be consumed in the reaction. D. What mass of water would be produced in the reaction. Each of these are worth 2 marks. And then E. Complete a mass balance for the reaction and verify the conservation of mass principle. Note here that in part E, this is a bonus mark, something that I've just added here for completeness in the question. Okay, so for those of you that just want to jump straight into an answer, into a solution, this is one that I stepped through earlier. So I'll just scroll through this for you now. Feel free to just pause the video and have a read in more detail the work solutions. I'll also have this up as a link in the video description. Okay, so let's get stuck into it. So for part A, we need a balanced chemical equation. Now guys, really this is your key bread and butter of chemistry here. If we don't have a balanced chemical equation, we won't have the correct mole ratios, and then we basically can't do the rest of the question. So we're starting off, we're told that it is propane gas, and it's ane, A-N-E, so propane as part of the alkanes. Pro is 3, so it's C3, and hydrogens, so the formula CnH2n plus 2. So it's going to be C3H8 for propane gas, plus, now oxygen, burning it in excess oxygen gas, reversible arrows to form CO2 gas plus H2O. So CO2 and H2O are the products of a complete combustion reaction. You also get that from basically just reading the question, mass of CO2 produced, oxygen is consumed, water is produced. Now I need to balance the atoms. So I basically just count, so I've got 3 carbons here, so I'll need a 3 here. Looking at hydrogens, I've got 8 here, so we'll need a 4 here. 4 by 2 makes 8 to balance that. And then finally oxygens, 3 by 2 makes 6, 6 and 4 makes 10, so I'll need a 5 here. Okay, so that now gives me the key mole ratios that I'll be using for the rest of the question. So 1 to 5 to 3 to 4. Okay, so that's part A solved. Part B, this is where we get into the real stoichiometry, or the mole calculations. Now, I'll just show this in more of a diagrammatic form for you. Essentially what we're going to be doing is starting with the mass of one of the reactants, the propane, mass. Then we're going to be calculating number of mole. Okay, the next thing, using the mole ratio, I'm going to calculate a new number of mole of some unknown, so I'll do that in green, some unknown mole. Okay, and the ratio that I'm going to use here is simply unknown over known. And I'll show you what I mean by that in a second. Once I have the new mole of the thing that I'm trying to calculate, I then calculate up and get to mass. So following this around is basically what I'm going to be doing for parts B, C and D. But in particular from here to here and here to here. Okay, so I'm told in the question that I start with 20.1 grams of propane. So that's basically the key basis for my question. So I'm going to write that. So I always like to start off any of my calculating by simply just writing out what I know. So that's the mass is 20.1 grams. Okay, now we work out the number of mole. Now the key equations that I've got to work with here for number of mole, so N is equal to small m over molecular weight is equal to concentration times volume is equal to PV over RT. So these are the extra couple of equations that you learn. Don't worry about them for now. I'm just going to be focusing on N is small m over big M. Okay, so calculating now the number of mole of C3H8. Which is equal to small m over big M, which is equal to 20.1 divided by, now for the molecular mass, guys, I'm going to assume that you know how to use the periodic table, and we're simply looking for the molecular weights. So we've got carbon 12, hydrogen 1, so I've got C3, so 12 times 3 plus 1 times 8, 36, 8, so it makes 44. So I'm going to write that straight in here. So sometimes for year 11s, if you wanted to step that out and actually show the calculation to get 44, in year 12 I like to just show my year 12s to write it straight off just to save time. So I punch in 20.1 over 44, 0.4568 mole. Guys, note here that I'm just going to leave a few decimal places, so in this case 4 decimals, and I'm going to round off at the very end to get to the appropriate number of significant figures as the question asks. So that's the number of mole of C3H8. Now I need to get to the number of mole of my unknown. So the thing I'm trying to calculate, remember, was CO2. Okay, so CO2, so this guy. So the number of mole now of CO2 is going to equal unknown, which is 3, divided by known, which is 1. So 3 over 1 times the number of mole of what I just used. So 3 over 1 times the number of mole of C3H8. So just to reiterate, unknown 3 divided by known 1. 3 over 1. Okay, so 3, 0.4568. Okay, so guys, I'm right-handed, so I do all my calculator pressing with my left hand, and I write with my right hand. A little trick I learned over the years. Okay, so that's the number of moles of CO2. Now the question has asked me for mass, so I convert to mass, and the way I do that is I just rearrange. Mass is mole times molecular weight. So the mass of CO2 is equal to N times molecular weight is equal to 1.3705. Now, molecular weight of CO2, carbon 12 plus oxygen, so oxygen is 16, as two of them is 32, 12 plus 32, 44, okay, 1.3705, so 1 times 44, 60.3. Okay, now, in terms of significant figures, if you recall up here, I had 3 significant figures for propane. So I'm going to round this down here to 3 significant figures, 60.3, and my unit is grams for mass. Okay, so that's part B solved. Part C, what mass of oxygen would be consumed. So again, it's going to be very similar to the question for how I did it for part B. Now that I have the number of mole of propane, I'm going to use the ratio to get my number of mole of the new thing, or the unknown thing that I'm trying to calculate, and then go back up to mass. So really just following dot, dot. Okay. So the number of mole of oxygen, O2, is going to equal, again, unknown, which is 5, divided by known, which is 1. Unknown over known, 5 over 1 times number of mole of C3H8. Okay, so that's going to be 5 multiplied by 0.4568. .284 mole. Okay, my mass of oxygen is going to be equal to, now again the formula, mole times molecular weight. I'm not going to bother writing, sorry, can't see that. I'm not going to bother writing N times big M again here, just to save time. So mass is 2.284. Molecular weight of oxygen, 16, there's 2 of them, 32. So times that by 32, 73.1 grams. Okay, A, B, C, part D. Again, mass of water being produced. So the moles of water is unknown for water, which is 4, divided by known, which is 1. So 4 over 1 times number of mole of propane. Propane was my basis. Okay, so 4, 0.4568. 4 times 0.4568, 1.8272 mole. Okay, and then finally converting this to mass of H2O is equal to the number of mole, 1.8272, times the molecular weight of water, hydrogen, so there's two of them, so 2 plus oxygen, so it's 18. So multiply this by 18, 32.9 grams. Okay guys, so there are the solutions to parts B, C and D. Alright, and now for the final part of the question. So we're asked for a mass balance for the reaction and verify the conservation of mass principle. So basically there's a law in chemistry that says matter cannot be created nor destroyed, merely just changes forms from one to the other. So in our case, let's have a look at how much mass we had in the beginning and compare it to how much mass we had at the end. So the mass of my reactants, so what did I start with? I started with mass of C3H8 plus the mass of oxygen. If you remember, the mass of propane was 20.1 plus the mass of oxygen, which I calculated, 73.1, and that is equal to 93.2 grams. I'm going to do the same process again for the products. The mass of my products is equal to the mass of I produced CO2 and I produced water in this reaction. CO2 was 60.3, calculated earlier, at part B, and mass of water 32.9, which I just calculated at part D. And now 60.3 plus 32.9, 93.2. What do you know? Matches. So, therefore, the conclusion here, therefore, the mass of the reactants is equal to the mass of the products, which is equal to 93.2 grams. Okay, so guys, that's the end of the question. From a marker's perspective, if I was going through this, really they're just looking for the correct answer, and failing that, for consequentials, just the way you've gone about and set it out. So 1 mark up here for the correct equation and balanced. At parts B, remember these were worth 2. B, C and D were each worth 2 marks. So you get 1 mark in here for the calculation step and the ratio. 1 mark to the correct answer, correct to the appropriate number of significant figures. Same here and here. D here and here. And finally 1 mark at the end for a correct. So that gives you a total of your 8 out of 8. Thanks for watching, guys. Please subscribe and comment below if you have any questions. Good luck with chemistry.